Okay, so the last section in this chapter is about how we write equations of lines. So we've looked at so far how to graph them using the intercepts, also using the y-intercept and the slope. We've also looked at how to find the slope, and now we're just going to put it all together and see how we can write equations of lines. So usually we use either what's called the slope-intercept form, which we briefly talked about, y equals mx plus b, right? And I'll just refresh your memory that this m here is the slope, right? And the b here is the y-intercept. We could also use something called the point-slope form. So the point-slope form is named that way because you have a point in the form. So the y1 and x1 are a point that the line goes through, and then m is still slope. So depending on what you have, you could use either one. So for the first example, we would like to find an equation of the line with slope 3 that passes through the point 1, 4. So I'm going to show you both ways to do this. So you could do it using either form. So let's first use the point-slope form because we have slope and we have a point. Okay, so if we do that, right, the point that we have here is 1, 4, and the slope that we have is 3. So in your equation, the y and the x here that don't have the 1s, those are the variables that stay in the equation, right? Our formula should have y and x in them. So using the point-slope formula is going to give us y minus 4, right? This is the y1 here, y minus y1. Okay, then equals m, which is 3. Then we've got x minus x1, and that's the x value of the point, and so that's 1. Now we want to do a little bit more with this, so we want to just write it as y equals. So we will distribute the 3 and then add 4 to both sides. Okay, so that gives us y equals 3x plus 1. So that is one way. It is probably the fastest way. Some people just like to use slope-intercept form, so I'll just show you how that would work. And you are welcome, of course, to use whichever you'd like. So with slope-intercept form, you need m and you need b. So the slope m is given to us. Now a formula for b, if you like formulas, if you solve the intercept form for b by subtracting mx and then plugging in the point, you can use this formula that b equals y1 minus m times x1. Okay, so what that tells us for our equation here, right, we're just going to plug in the point, right? So we still have that same point over here. x1 was 1 and y1 is 4. Okay, so the y value of the point is 4. Our slope was 3, and x1, the x value of the point is 1. So we get 4 minus 3, which is positive 1. Okay, so we have m and we have b, and so when we put that together, we get mx plus b. Oops, not b, b was 1. And so either way, you'll get the same thing. So like I said, make it yours. Whatever you want to use is totally fine. You should get the same thing either way. I will vary from question to question just to give, and I use some exposure to both of them. So here, we would like to find an equation of the line passing through the points. Okay, so here we don't have m and a point. Here we just have 2 points. Excuse me. But it still stands that we still need m and b. Okay, so that will not be different. So we still need m and b. All right, so m, the slope, well, lucky for us, all you need for finding slope is just 2 points, right? It's y2 minus y1 over x2 minus x1. Right, so we've got x1, we've got y1, we've got x2, we've got y2. And so when we plug these in, we'll have 2 minus 3 over 6 minus 1. 2 minus 3 is the negative 1. 6 minus 1 is 5, and so there is our slope. Okay, so at this point, now it's kind of like the previous question that we did. So we have slope, and we also have 2 points we can pick from. So you can either use this formula that I showed you for b over here, plug in a point and then find b, or what you can do is you can go straight to the point slope formula. We have m, and we can just use one of the points to plug in. So it's totally up to you. I will just use point slope formula for this example. Okay, so we're not going to find b in this case. I mean, we will inadvertently, but we won't explicitly find b. So for point slope, we need a point, so you're just going to choose one of them. It doesn't matter which one. I'm just going to choose the 1 and the 3 because 1 and 3 look like they're smaller and easier to work with. So we have y minus y1, so that's 3, equals m, which is negative 1/5, times x minus x1, which is 1. So there we go. We don't want to leave it like this though. Let's distribute the negative 1/5 inside. Okay, negative 1/5 times x is negative 1/5 x. Negative 1/5 times negative 1 is plus 1/5. Okay, and then lastly we want to add 3 to solve for y. Okay, 1/5 plus 3. Let's come and do some scratch work down here. So 1/5 plus 3, we need a common denominator. So we're gonna, this is really 3 over 1. So we'll multiply, oops, this is a plus here. We're gonna multiply by 5 over 5. Okay, so it's 1/5 plus 15 over 5. Now we can add the numerators, we get 16, and we leave the denominator the same, so 16/5. All right, not the prettiest equation, oops. And I'm sorry, I didn't mean to drop this negative here. So in the end, we should have y equals negative 1/5 x plus 16 over 5. All right, let's do the same thing. So here we've got 2 more points. So still we need m, right, slope. So y2 minus y1 over x2 minus x1. Okay, let's label these. So here's x1, here's y1, here's x2, here's y2. Okay, so let's form our slope fraction here. So y2 is 0, y1 is negative 2. Be careful with your minus and the negatives. Okay, x2 is negative 2, x1 is 0. So it looks like we have a positive 2 up top and a negative 2 in the bottom. And so when we simplify, that gives us negative 1. All right. Excuse me. So now we have a choice. We can use point slope, or we can find b and then plug into y equals mx plus b. It is totally up to you. Again, just for sake of showing you different ways, I'm going to just use the other method. So let's find b. Okay, so again, b equals y1 minus m times x1. And that's not some crazy formula. It literally comes from here by bringing this over to this side by subtraction and just solving for b. Okay, so let's see. Pick any of the points that you want. So y1 we said was negative 2. We've got minus m, which is negative 1, and x, which is 0. So we've got negative 2 minus 0, and so that's negative 2. And so now putting this into our mx plus b form, we've got negative 1x minus 2, or just negative x minus 2. And so there we go. All right, I've got a couple more for us here. Okay, so we've got now 2 points again, and we still want to do the same thing. So first thing, find the slope. So y2 minus y1 over x2 minus x1. All right, y2 minus y1, so let's label these x1, y1, x2, y2. All right, so 1/2 minus 1/2 over 3 minus 4. All right, 1/2 minus 1/2 is 0. We've got over negative 1. 0 over any number is 0, so slope is 0. All right, and then just to switch it up here, I'll use point slope formula. All right, so that's the y minus y1 equals m times x minus x1. So let's plug in. So we have y minus 1/2 equals m, which is 0, times x minus 4. So I'm just using one of the points. I'll just use this point here. So this is y1, this is x1. Okay, so, I mean, I don't know, we could distribute the 0, but really 0 times anything is 0, so we just have a big fat 0 on the right-hand side. We want to solve for y, so we'll add 1/2 over, and so there we go. That should make sense, right? We have a slope of 0. We know that horizontal lines have a slope of 0, and so what we got here is a horizontal line, right? Y equals a number is a horizontal line. Oops, so we could write that down. So horizontal line. All right. Moving on here, so we got another one here with 2 points. So again, we want to find the slope. So let's do x1, y1, x2, y2. Okay, y2 minus y1. That's, let's see, 6 minus 9. Then we've got negative 4/5 minus negative 4/5. 6 minus 9 is negative 3. This will be negative 4/5 plus 4/5. That looks like it's 0 in the bottom. So this is undefined slope. Right, this is undefined slope. So we can't possibly put that into an equation, right, if it's undefined, like if we don't have m. But remember, undefined slope, what does that mean about the line, right? It means we have a vertical line, straight up and down. So those look like x equals a number. Those look like x equals a number. And so all you need to do is look at the x values here, right? So negative 4/5, negative 4/5. So the line we're finding is the vertical line with formula x equals negative 4/5. Right, and I didn't mention over here, but right, this horizontal line, y equals 1/2. Here we just have 2 different x values, but the same y value. Right, so if you were to graph it, it'd just look like this. Same y value no matter the x value. All right, just got a couple more here, pulling some pieces together, synthesizing ideas. We're going to find an equation of the line passing through the point 1, 2 that is also parallel to this line here, 3x minus 2y equals 4, and then also one that's perpendicular. All right. So for part A, right, we have a point. We don't have the slope, right? But if we know that we want to find the line that's parallel to this one, what we've got to do is find the slope of this one, and then we'll have the slope of the line we're looking for. Okay, so find m, right, so parallel to 3x minus 2y equals 4 means they have the same slope. Parallel, same slope. So let's find the slope of this line. Like, what is its slope? it's not always just the number in front of the x. We have to get it in y equals mx plus b form, right? So let's solve this for y. So I might subtract 3x from both sides. And then divide by -2. So everything gets divided by -2. Okay, so we get y equals now positive 3/2 x, and then this will become -2. Okay, so the slope we're looking for is 3/2 now, right? And now what we have is a slope of the line that we want, and now we want the one that passes through this point. Okay, so totally up to you what you want to do. So this is m. I'm going to use the b formula. So b equals y1 minus m times x1. Okay, so the point, so here's the x1 and the y1. So we have 2 minus 3/2 times 1. So that's 2 minus 3/2. Okay, we need a common denominator here. So how many halves is 2? That's 4, right? Multiply 2 over 2. And so that gives you 1/2. Okay, so the equation we're looking for is y equals 3/2 x plus 1/2, right? mx plus b. All right, for part B, we're looking for the line perpendicular to the same line, okay, but now with the same point, but now perpendicular. Okay, so again, we need to find m. Okay, perpendicular, I'll remind you what that means. Perpendicular to 3x minus 2y equals 4. That means they have negative reciprocal slopes. Negative reciprocal slopes. Okay, so we know that the slope of this is 3/2. So the perpendicular slope, right, the perpendicular slope, the one we're looking for, is going to be -2/3, right? We flip the numerator and the denominator and negate. Okay, so here's our m. Now we also need b. Okay, so y1 minus m times x1. It's the same point, right? So it's 1, 2. So 2 is the y. We've got -2/3 for our slope. And x is 1, right? X was 1, yeah. All right, so this comes out to be 2, then plus 2/3. Okay, we need a common denominator. So 2, how many thirds is 2? We're going to multiply by 3 over 3, and so that gives you 6/3. And so when you add those together, same denominator, but you add the numerators, and so you get 8/3. And so putting this into mx plus b, we have -2/3 x plus 8/3. And there we go.